Hello everyone, this is Min Xiu Wang. In this short video, we'll solve a simple problem together. Let's see the question first. Assume that the argument n is an integer and is equal to 1. Each integer is printed out in a field of size equal to the number of digits in n plus 1. The output is printed out, not returned. It seems like it's just a format requirement, and we don't know what they want me to do, right? So maybe we should see the example first. In this example, when n is equal to 1, we just output 1, little information. In this example, when n is equal to 2, in the first line we should output 2 and 1. In the second line we should output 2. Still don't get it. In this example, the first line should output 8, 4, 2, 1. The second line is 7, 3, 1. The third line is 6, 3, 1. It seems like there are some patterns that we can discover. Let's see it. The half of 8 is 4. The half of 4 is 2. The half of 2 is 1. The half of 7 is 3.1. And 3 is the rounded down of 3.1, so 3.5. The half of 3 is 1.5, and 1 is the rounded down of 1.5. The same pattern can be also applied to the following output, as you can see. It seems like this is the right pattern that we discovered. So let's verify our idea with the following example. When n is equal to 13, the first line 13, 6, 3, 1. The half of 13 is 6.5. 6 is the rounded down of 6.5. The half of 6 is 3. Yeah, the half of 3 is 1.5, and 1 is the rounded down of 1.5. As you can see, our pattern can be applied to the whole output. And the first number is just decreasing by 1. Yeah. In this example, our pattern can be also applied. Oh, but don't forget, there are some format requirements we just read it at the beginning of this video. Let's see the format requirement with the example. In this example, 13, 1 space, 6, 1 space, 3, 2 space. This is also 6, 2 space, 1, 2 space. The size of 13 is 2. 2 plus 1 is 3. So for each small part, there are 3 space holders for each small part. So we have discovered all the pattern. Let's write the code together. We can use a variable mass length to store the length of n plus 1. That's also the length of the part we shall output. And as you can see, there are n lines, so we can use a for loop to achieve that. Each number is divided by 2 until it's 0. We can use a temporal variable k to achieve that. As you can see, in the beginning of the line, k is equal to I. So we should initialize k as I. And we can also use a variable line to store the output of each line. Obviously, it should be initialized as empty. As long as k is not to 0, it's not equal to 0, we should keep dividing to k by 2. until it's 0. In Python, this is divided k by 2 and rounded down if there are remainder. So we should output the 9. Let's run it. Passed, 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 passed also. Passed also. Passed also. So that's all. We have saved the problem together. Thanks for your watching and listening.